All right, now we are going to look at the distributive property. And the distributive property is this rule right here. And it might look a little confusing until we actually do it with some numbers. So we're going to go through this first example here. And the distributive property is when we have parentheses and there's something on the outside of the parentheses. So if we look, this 5 is squished right next to the parentheses here. That means it's being multiplied. And it's being multiplied by everything inside the parentheses. So that's why there's 2 arrows, because we have to multiply it not only to the x, but also to the 6. So the first thing we're going to do, and we like to draw arrows so that we remember what we are multiplying so we don't forget something. We're going to multiply the 5 times the x. So we would get 5x. Then we multiply the 5 by this positive 6, because that plus sign goes with that 6. So 5 times a positive 6 is a positive 30. So we're going to put plus 30. And that's it. So whenever we see parentheses, we first want to use our distributive property to simplify it, and then we can solve it like a normal equation. So there's 2 u tries. I'm going to go ahead and do the one on the right, and then you guys can do the one on the left. So for the one on the right, I'm going to actually zoom in here. So we have 9 equals 3, and then parentheses, z minus 6. So that 3 has to get multiplied by everything inside our parentheses. Okay, so everything in there. So I'm going to start by distributing this 3 to the z. That's the first thing. So 3 times z is 3z. And then I multiply the 3 by the negative 6. 3 times negative 6 is negative 18. So we're going to put minus 18. And we did not do anything with that 9, so we're going to bring the 9 straight down with that equal sign. So we have 9 equals 3z minus 18. Now we can go ahead and solve it. Again, we want to draw a line through our equal sign, and we're going to find where our variable is and figure out what is the furthest from our variable. So our variable is over here, and we either want to get rid of the 3 or the negative 18 first. The negative 18 is the furthest, so we want to undo that. So right now it's being subtracted. So the inverse of subtraction is addition. So we're going to add 18 here. And we also have to add it to the other side of our equal sign, so we're going to add it over here. We got to make sure it stays balanced. Now our new equation, so we're going to simplify it. I'm going to go left to right. So 9 plus 18 is 27. Ooh. So we get 27 equals 3z. Nothing happened to that, so we're going to bring that straight down. And then that minus 18 with the plus 18, those cancel because they're inverses of each other. So we're just going to leave that blank. And we can cross it out if we want to. So now we want to go ahead and get rid of the 3 that is next to our variable. And if we look, they're squished together. So when they're squished together, we know that they're being multiplied. To undo multiplication, we are going to divide both sides by 3. And that means 27 divided by 3 is 9. We have our equal sign. Those 3's are going to cancel and give us 1. So we're going to have 9 equals z, and that is our answer. If you want to write it so the variable's on the left-hand side and wrote z equals 9, that is totally fine. Either or. So go ahead and pause the video, and you guys can do the u try on the left, and I'll give you the answer in a second. All right, so you should end up with m equals 7. You want to first start by distributing that 4. You distribute that 4, and then you can add 24 to both sides and then divide by 4. All right. So that was the distributive method. Now we're going to go through checking our work. So it is extremely important for us to check our work because we want to make sure that we're correct. If we're doing all this work and we don't know that we're correct, then it's kind of silly. So to check our work, we want to plug our solution into the original equation. Okay, so our solution is when we get like z equals 9 or x equals 4 or m equals -1. That's our solution. So we plug that into original equation. And then we ask ourselves, is this true? If it is true, then our answer is correct. If it's not true, then we need to fix the problem. We need to redo it and resolve it and try to figure out where we went wrong. So we have an example here. It says Mandy solved the equation 2x minus 1.3 equals 0.7 plus x and got an answer of x equals 4. Is her answer correct? So what we're going to do is we're going to take this x equals 4. This is a solution. And we're going to plug that number 4 in wherever we see the variable x, which means we're going to plug it in right there and right there. Okay, so what we're going to have is we're going to have 2, because there's a 2 outside of the variable. And then that 4 is going to replace our variable x. So we're just going to put it in parentheses. We have minus 1.3 equals 0.7 plus, and then x, we're going to plug in that positive 4 here again too. You don't have to have the parentheses for that one because there's nothing in front of that variable. We needed it here because there was that 2 out in front. If you don't have the parentheses, it looks like 24, and that's not what we want. So now we want to simplify each side of the equal sign. So we're going to start with the left-hand side. So we want to do 2 times 4 minus 1.3, and we can type that into our calculator, parentheses and all. So when we type that into our calculator and simplify that, we get 6.7. So on this side, we get 6.7. And then on the other side, we do 0.7 plus 4. When we add those, we get 4.7. I cannot simplify that any further. So then I can ask myself, is this correct? Is 6.7 equal to 4.7? No, those are not equal numbers. So that means Mandy's answer is wrong. So x does not equal 4. So she would have to solve it again. Okay, so we can say no. She is not correct. 6.7 does not equal 4.7. And that's the does not equal because the equal sign is being crossed out. So you guys can go ahead and do the U-try. Go ahead and pause it. And then I'll let you know the answer. All right, when you plug in -3.5 in for m, you should get -3 on both sides. So yes, his answer does make sense.